Hey everyone, Mr. Andrew here. Today, I wanted to talk to you about data and how we analyze that data. So, anytime that you're doing any kind of quantitative experiment, you're going to be collecting data. That's what quantitative means. It's involving numbers. So, when we're generating data, we need a way to analyze that data. And there are a lot of different measurements and calculations that we can use to analyze data. But today we're going to look at two of them. The ones we're going to look at are mean, which many of you are probably familiar with, and standard deviation. Okay? So to start out with, let's say that I had just a data set. And let me make just a quick set of values. Let's say it was 5, 4, 6, 5, 5, 3, 7, 5, something like that. Okay? So you're performing an experiment, you take a series of measurements, and these are the values you get. I want to analyze this information to try and get more out of it, to look for patterns or anything like that. The first thing that I'm going to do is I'm going to calculate what's called a mean. Okay? A mean is just simply an average. Okay? It's basically where's the middle of the data. Okay? Now, in your math classes, undoubtedly you've learned how to calculate a mean or an average. The way you do that is you add up all your data points and then you just divide by how many data points you had. In this case, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, let me pull up a calculator real quick. If I were to add up all these data points, 5 plus 4 plus 6 plus 5 plus 5 plus 3 plus 7 plus 5, I'm going to get 40. Okay? Now there's 1, 2, 3, 4, 5, 6, 7, 8 data points, so I'm going to divide it by 8, and boom, my mean is 5. Okay? But there's actually a much faster way and a much easier way that you can do this. And the way you're going to do that is you're going to use Google Sheets. Or you can also do this with Microsoft Excel. What you're going to do is you're going to pick the cell that you want your average to be put into. Okay? And you're going to hit the equals key. Okay? When you type the equals key in a cell, you're telling this, we're going to do math here. We're going to do some kind of math calculation. Now, you can do something really simple, like 2 plus 2, and boom, it will spit out the answer to what 2 plus 2 is. 2 plus 2 is 4. But we want to do something a little bit more complicated here. Okay? We want it to calculate the average for us. So, I'm going to start typing the word average, but really I just need to type the first 3 letters. Okay? Now, it pulled up all of these different versions. What I want is just the one that says average. So I'm going to click on that. Now you'll see in my cell right here, it put an open parentheses. If I start typing numbers separated by commas, 5, 4, 3, 5, whatever, it will try and take the average of those numbers. But instead of having to type all of our data, I don't want to do that. That's way too much work. Instead, I'm going to click and highlight the data that I wanted to take the average of. So I'm going to click and hold and drag to highlight my entire data set. Now these are cells B3 to B10. And if you look in my equation right here, it says B3 colon B10. That's saying it's taking the average of every cell starting with B3 and ending with B10. I'm going to close off the parentheses, hit enter, and boom, it calculated my average for me. My average is 5 exactly. Okay? Now the good thing about this is that if our data set were to change, it will recalculate the average for you. So let's say you made a mistake and you accidentally typed 6, but in actuality this 6 is an 8. You fix it, and the average fixes itself for you. So no need to do extra work, okay? So that's how you find the average, which is basically the middle of the data. But we want another piece of information. We want what's called the standard deviation, okay? The standard deviation is a measurement of how reproducible your data is. Okay? So, I want to figure out how close my data is to the average. So, I'm going to use standard deviation to do that. Okay? Standard deviation just means for each individual data point, how far are they away from the average? Okay? So I'm going to calculate this the same exact way as I did my previous one. The only difference is instead of typing average, I'm going to type ST. And when I do that, STDev pops up. That's the standard deviation. And you see the same open parentheses, so I'm going to highlight again. I'm going to close it off. And my standard deviation is 1.2. With standard deviations, the lower the standard deviation, the more reproducible your data is. Let me show you what I mean. Okay? I'm going to tweak my data set so that way my average stays the same, but it's going to change my standard deviation. So let me show you. This 7 and 3 right here are the furthest away from my average, right? 3 is 2 less than my average. 7 is 2 more than my average. If I change both of these to 5, my average stays the same. It's still 5, but my standard deviation is much lower. Why? Because on average, most of these numbers are equal to my mean. But let's change it up a little bit. Let's instead make this 55. That's 50 more than my average. And I'm going to make this negative 45. That's 50 less than my average. So now my average is still 5. If you add all these up and divide it by 8, you're still going to get 5. But my standard deviation is much higher. This shows that my data isn't as reproducible. Okay? Lower standard deviation, more accurate. Excuse me, not accurate, precise. Lower standard deviation, more precise, more reproducible. Higher standard deviation, less precise, less reproducible. So hopefully this helps you. If you have any further questions, let me know.